Ladies and gentlemen, welcome to the Campbell Cyber Podcast. In this episode, I'm going to be giving you the overview for how to build your own computer. That's right, it's going to be custom built. Maybe you've been thinking about doing it for a while, and maybe you need just a broad overview of what all the components do, what to watch out for, what to buy, things like that. Well, this is the podcast for you. So what I'm basically going to do is I'm going to run through all of the components of the computer, kind of what they do, what they're for, and things to watch out for, especially when it comes to building your own PC. So let's get right into it. So the first thing that you need to know about building your own computer is something called the CPU. And if you're looking at building your own PC, you're probably already familiar with what a CPU is. It stands for Central Processing Unit. And you can also refer to this as the processor of a computer. But essentially, all of the different components in a PC are basically there to support the processor, the CPU, in what it does. All of the different calculations, all of the different processes that run, they all basically get run through the processor of a computer. That's really what the computer boils down to. All of the RAM, all of the hard drive, all of the cooling, it's all to support the CPU. And the CPU is really going to be the core component that determines the speed of your computer, how fast it goes, how efficient it is, how much power it uses, stuff like that. So it's very important to pick a very good processor for your first computer build. Now, I'll talk about kind of two of the main characteristics that processors have. The first one is processor speed, and you'll see this measured in something called gigahertz, which is basically billions of cycles per second. So each CPU nowadays is measured in gigahertz, which you'll see like a 1 gigahertz processor means it processes at 1 billion cycles per second. And you'll see processors that go up as much as like 4 to 5 gigahertz. The speed of your processor is obviously very important because that's going to determine how fast your computer can go. The other characteristic that processors have is something called cores. Now, basically, cores are basically subprocessors within the main CPU. What cores do is they basically disperse the workload of the processor into a bunch of little parts. So if you have a 4-core processor that runs at 4 gigahertz, that basically means you kind of have 4 processors running at 4 gigahertz, and anytime you get a new task for that processor to do, it gets split up amongst 4 cores, and then it can do that 4 times as fast. So the number of cores in your processor will also help determine the speed at which your computer goes. Now, when it comes to the pricing of these processors, generally speaking, a lower gigahertz processor is going to be less expensive, and it's going to be, a lot slower, unfortunately. But a higher price processor is going to give you that extra gigahertz, it's going to give you more cores, and it's going to be faster. Now, the two main companies that manufacture processors are Intel and AMD, and they build different types of processors for all types of different PC builds. So if you're trying to build something on more of a budget, they have very good processors that are a little bit more budget friendly, but they also have the high-end processors as well. So one rule of thumb that I kind of go by, and I mean, both companies are great companies, but historically, on average, the Intel processors have had a little bit better technology associated with them. The AMD processors, that although they're still good processors, those are going to be a little bit more budget friendly. So if you're building like a gaming PC, and you get like a high-end Intel processor versus a high-end AMD processor, the AMD is going to be a little bit cheaper for roughly the same performance, but the Intel is going to have slightly better technology and might give you an edge on performance. So it really depends. There's a lot of different websites that do like benchmark tests to help you determine the best processor. Both companies are great companies. You'll see great reviews from both. So that's how you go about picking a processor. So the next thing you need to look out for when you're building your own computer is something called the motherboard. And once you have your processor selected, you want to pay attention to something called the socket type of the processor. And basically, the CPU of a computer, the processor, has a bunch of these little tiny pins on the backside of it that plug into the motherboard. And these pins are organized in a way that are unique to each processor, and that is what they call the socket type. So what you want to do is once you pick a processor, you want to pick a motherboard that has the same socket type as the processor you picked out. Otherwise, the processor is not going to fit on the motherboard, which would be very problematic. The motherboard of a computer basically houses all of the different components and organizes them. So this is where you're going to have your CPU get plugged in. It's where you're going to plug in all of your fans to. It's where you're going to plug in your RAM, your hard drives, your graphics card. It's basically like the central hub of all of the different things that basically run your computer. So you want to make sure to pick a motherboard that isn't too much on the cheap side because it's basically going to connect all of your different components together. One thing to take into account is kind of the spacing on your motherboard. If you plan on getting a really big graphics card, you want to make sure you have a motherboard that will support that graphics card. If you plan on possibly having multiple graphics cards, you want to have a motherboard that supports that. You also want to pay attention to how many different RAM slots there are on the motherboard. Some only come with 2, some come with 4, and that will depend on how much RAM you want to use, which we'll get into later. But your motherboard is something that you do not want to skimp too much on because having a crappy motherboard is going to give you headaches down the road when you're trying to plug things in and trying to arrange things. If the motherboard doesn't really work that well, it's just going to create frustration. So try to do your research on a good motherboard to use. If you're more budget-minded, don't skimp too much on the motherboard, but also you can definitely get some very, very premium motherboards as well. The next item that I want to talk about is the RAM of a computer. Now, the RAM was always a concept that kind of confused me, so I'll try to explain it in the best way possible for you to understand. RAM basically stands for Random Access Memory, and they come in these little sticks that they just like plug into the motherboard of the computer. And what Random Access Memory does is they basically act as a bridge between the hard drive and the CPU. So if you think of your computer as kind of a flow of information, you have to load your information from the hard drive, and then you have to process that information in some way, and then it gets back to you as output. So say you're playing like a video game, right? Well, your video game has all of the information stored on the hard drive, and eventually it has to get processed. You know, you're shooting aliens, or you're even on the loading screen trying to load a map, right? It has to get processed somehow to deliver the output. Well, there was a problem with how hard drives are made, and hard drives are designed to have very large amounts of space, but very slow speeds. And that's just kind of the nature of hard drives, right? If you want to store more things more affordably and cheaply, you are going to sacrifice the speed, right? And so that's where RAM comes in. So basically, whenever you load up a program, it loads up from the hard drive, and then it puts it into RAM. And then that way, when you're playing like a video game and you're shooting aliens, it doesn't have to load things from the hard drive, which would be very, very slow, and your computer would run enormously slow. And it pulls it from the RAM so that it can run it very fast and efficiently. Now, one thing that you may have noticed on older PCs that you have is they get slower over time. And a lot of times what happens is the programs, because they're getting newer and newer, they are more resource intensive and they use up more RAM. And if the RAM gets full, say you only have like 4 gigabytes of RAM, but you have a program that requires 6 gigabytes of RAM, if you don't have enough RAM to hold all of the information for that program, your computer will, in effect, start to go very, very, very slow because it's not able to pull information from the RAM loaded from the hard drive. It has to pull it directly from the hard drive, which is very, very slow. So hopefully I've encapsulated that in a way you guys can understand. RAM basically sits between the hard drive and the CPU, and the more RAM you have, basically the faster your computer can go because it can load more information and prep it for processing by the CPU. Now, usually RAM comes in sticks of 8, 16, or 32. For most computers, 16 gigabytes is going to be more than enough. If you're really into gaming, perhaps consider 32 gigabytes of RAM because that's going to help you just get that extra boost of performance. If you're on a really budget build, 8 gigabytes will get you by, but it's something you might want to consider upgrading later. The other good thing about RAM is that it is very easy to upgrade. So if you get a motherboard with like 4 RAM slots and you just want to start small with like 8 gigabytes of RAM, that's super easy to do, and it's super easy to install more RAM later. You basically just go buy more sticks of RAM and plug it in. It's literally that easy. It might require a little bit of configuration on the motherboard side, but it is very easy. I've done it many, many times in my job as an IT technician. If you're going to try to save some money and upgrade later, this is a great place to do that. Now that brings us to our next thing for our PC build, and that is hard drives. So I've already kind of mentioned this when I was talking about how RAM works in conjunction with the CPU, but I'm going to give you an overview of hard drives and how they work and the different types of hard drives that you can use in your PC. And basically there are two different types of hard drives that are kind of standard nowadays. The first type of hard drive is your traditional hard drive. They call it a hard disk drive, HDD for short. And this is a hard drive that has been around for years and years and years. And what it actually is it actually has a physical spinning disk in it that physically moves, and it's got a little needle that reads off of the disk. And these hard drives are a lot cheaper because they're a lot more established, but they are slightly slower than the different type of hard drive that I'm going to mention here in a sec, which is an SSD. But overall, classic hard drives, or HDDs, are very, very reliable. They move definitely at a pace fast enough that you can definitely get by with these. Many computers have used them. They run very well, they're very reliable, and they do the job very well. Now, on the other side, you have SSDs, which stand for solid-state drives. And what solid-state drives are is they've been around for a few years, but they're relatively newer compared to normal hard drives. And solid-state drives don't have any physically moving components. That's why they're called solid-state drives. And because of this, they're actually way faster than those normal spinning hard drives. And they're actually technically more reliable because a physical disk that's spinning can fail. It can break. Whenever you have moving parts, things can go wrong, right? So solid-state drives are going to be faster, and you're going to have a little bit better reliability. Now, the drawback to SSDs is they are a lot more expensive than your classic hard drives. So there's a trade-off there, right? One of the things to keep in mind is you can also mix and match hard drives. So if you want to build a computer that loads up really fast, but maybe have something cheaper that stores all of your games and stuff that you don't use every day, you can have a small storage SSD that you load your OS on, and then you can have your HDD, your hard disk drive, that has like a terabyte of space that holds all of your games and all of the programs that you want to run. And that combination actually works really well. There's a lot of computers that do that. Or you can just implement an SSD, or you can just implement a normal hard drive, and things will still work out really good. So those are kind of the differences between, the different types of hard drives you can get. So the next component in a computer is what we call the graphics card. And this is where the gamers are going to come in, because your graphics card plays an absolutely massive role in what type of gaming you do. And there's a whole range of different graphics cards you can get. And it really depends on what level of performance you want. Now, I said at the very beginning that the processor is kind of the main part of the computer that processes everything. When it comes to graphics cards, it's exactly like what it sounds. The graphics cards, if you're running, a gaming PC, or you're running different types of graphics, those processes are actually going to get run through the graphics card. The graphics card has its own processor, and it processes all of the graphics for your computer. So if you're playing gaming and you have a lot of different like shadows and rendering that you have to do, your graphics card is going to play a big role in how well your game runs. And you have low-end graphics cards, high-end graphics cards. On the lower end, you can spend as little as like $200, $300 for a relatively decent one. On the high end, you can spend as much as like $3,000. They get really, really crazy. So NVIDIA is a big player in the graphics card industry. They have a whole range of graphics cards. I would look there because they're kind of the industry standard. But there's also other graphics cards companies like AMD. They make some graphics cards. And then there's also some other companies that do that as well. So graphics cards are highly dependent on gaming. Again, go to like a website that does benchmarks. You can benchmark how different graphics cards compare to one another. There's really like an endless supply of them. So I recommend kind of going to a benchmarking website to kind of see how different graphics cards do. Now, if you're building a PC and you're not going to do a ton of gaming on it, or very low intensive gaming on it, You can actually opt to not get a graphics card because most CPUs have built-in graphics processing. Now, you want to double check and make sure your CPU actually does this, but for like most laptops and most computers that like businesses buy, they don't buy them with graphics cards. It's all included in the processor and it's just all run through the processor. Again, only do this if your gaming isn't going to be too intense. If you do more intense gaming, you're definitely going to want to have a graphics card, but for something like really simple, like if you're playing like Zoo Tycoon or something like that, something that isn't like graphics intensive, your processor will actually work great. Now, the next thing you need to keep in mind for building a PC is the power supply for all these different components that you have, right? They're all going to require power. Your processor, your RAM, your motherboard, your hard drives, your graphics card, they're all going to suck power. And you want to pick a power supply that is going to have sufficient power for your PC. So one thing that I recommend you do is you can actually go, there's sites out there that you can go and you can plug in all of the different components that you're going to have in your PC build, like all the different models, your model of processor, your model of RAM, your model of graphics card, and it will actually calculate how much watts you need in your power supply. And your power supply basically functions as a device that sits between the outlet of the socket in your wall and the components of your computer. And it basically takes the power from your wall, divides it up, and feeds it into all of the different components of your computer. Now, when it comes to power supplies, there's kind of two main types. One is a non-modular power supply where all of the cables are hooked into the power supply and you can't remove them. And another one is called a modular power supply where, sometimes you might not need all the cables. Like if you don't want to implement a graphics card or you don't have a bunch of fans or anything in your PC. Sometimes it's nice to be able to unplug some of the power cables from your power supply just to kind of make things more organized. So those are the two types of power supplies. And then they're also going to be rated by wattage. So you'll see a 500 watt power supply, 850 watt power supply, 1000 watt power supply. Again, go to one of these websites, go plug in all of your components because they use different amounts of wattages. Obviously, if you have like a really big processor and a really big graphics card, you're going to use more wattage. That will help you determine the type of power supply to get. The next component in your PC, and we're almost done, we're down to the last couple, is going to be cooling fans. So obviously, a PC runs very, very hot, and heat is the enemy of all computer systems. If things get too hot, components start to melt and your PC starts to shut down. So what will happen is if things get too hot or the temperature gets too high on your PC, usually the motherboard will automatically start slowing everything down, and everybody hates slow computers, especially me. So you want to make sure to get lots of cooling fans for your PC. And you're going to kind of have two types. You're going to have kind of your main cooling fans that cool just the inside of the PC, and then you're going to have the actual processor cooling fan that is going to be dedicated to cooling your processor, because your processor gets very, 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 very hot. And a lot of times when you buy a processor, it will actually come with a built-in cooling fan. Like it'll come with something called a heat sink, which is basically a big piece of metal designed to disperse the heat. You put it right over the processor, and then you hook a fan to it, and then it just blows air. Another type of cooling fan you can get to cool off your processor is actually something called water cooling. And what it is it still uses fans, but what it does is it uses water to basically transport the heat away from the processor, and it gets expelled from the computer, and the water just acts as a heat transport mechanism. So you're not like filling anything with water. It's already kind of built in there. But it tends to be quieter, and it tends to actually cool a lot more effectively than just using standard cooling fans. If you value something that's a bit more quiet, water cooling is a great option for you, but it's also a little bit more on the expensive side. Normal cooling fans have also come a very long way. You can get a very quiet PC. So if you just want to use kind of the built-in cooling fans, or just get some cooling fans that have, a low sound rating, those are really good options for you. The next thing I want to talk about is the computer case that you get. So there's going to be a bunch of different sizes of computer cases out there, and you want to pay attention to the size of your motherboard in order to pick out the right case. So the different types of cases are like, I know ATX is a type of size. There's micro ATX. your motherboard is going to determine the size of case that you need to get for your computer, because if you have a really big motherboard, you need to make sure to get a case big enough to house it. Now, when you're researching cases for your PC, you want to pay attention to a couple things. Number one is what type of cooling comes with the case. A lot of them come with built-in fans, but some of them don't. So you want to take that into account, because sometimes you can use the cooling fans that come with the case. Other times you might want to buy some extras. Another thing to consider is the cable management of the case, because sometimes you'll get a computer case and a lot of the cables are just going to be strewn all over the place. But there's other cases that you can get that you can actually like route the cables behind different types of metal to kind of make your PC more aesthetic and make it organized better. So that's another thing you want to watch out for. So that's basically all you need to worry about when it comes to cases. Make sure you get the right size. Make sure you pay attention to cable management. Make sure you pay attention to cooling. Now, the last thing that you'll want to keep in mind when building a PC is the cost of installing Windows. Now, if you're a Linux user, you don't really have to worry about this because Linux is open source. You can just install it. But Windows is going to cost you like around $120 to $140, kind of based on whatever version you get. It's a very annoying cost that you have to incur if you're building a custom PC, but it's also Windows, and I'm a Windows user, so you just have to factor that into account as you're building it. Say, okay, here's the cost of my PC, and then add an additional $150 or so to install Windows, because I always forget about that when I'm budgeting out PCs, and you don't want to get to the end and then not be able to use it because you forgot to buy Windows for it. So those are basically all of the essentials to building your PC. Now, there's a ton of YouTube videos and resources out on the internet for how to build your computer. I recommend one that's called Linus Tech Tips. They're a computer building company that they basically have a ton of YouTube tutorials on how to build your own PC. Go watch a couple of those, get used to seeing how it works, seeing how PCs are put together, and that will help prepare you to build your own computer. It's definitely a fun time building your own computer. You get kind of that ownership aspect. It's a lot of fun researching a lot of the different components, and it's definitely a very rewarding experience. So hopefully this podcast was helpful to you. I want to thank you very much for listening. Make sure if you enjoyed this podcast to go give it a review on iTunes, and I will see you later.